Salam. Let's complete the second part of the lesson, and actually you just remember you're dealing with carboxylic acids. So we're going to study the reactions that the carboxylic acids can make. In general, the acids can react with alkaline solutions that contains OH negative, and they also react with carbonates, okay, and react with metals. Okay, so we're going to study what will happen as a result of reacting between carboxylic acids and all of these species in here. So let's start with the first one, which is considered as a redox reaction, which is between metal and carboxylic acid. So suppose that you have a carboxylic acid like CH3, COOH, and it reacts with, let's take any metal like Na, and you will have CH3, C double bond, or let's say OONA plus H2. So once you make a reaction between metal and acid, you will have hydrogen gas as a result of the redox reaction, and then you will have salt. So this is salt, all right? What do you conclude about this? You can say, like, where is the redox reaction in here? You just notice that the oxidation number here is +1 and then it turned to 0. So you notice that there is a reduction of hydrogen in here, whereas the Na was 0 and then it turned to +1, and here we have a redox reaction actually. The observation is you notice the fizzing or bubbles or stuff, and you can test this gas by the light splint and it gives pop sound. So this is the first reactions that you have. Let's go to the second reactions of the carboxylic acids. Another thing you could put in your mind, you can make a reaction between carboxylic acid and another metal like magnesium, for example. But the only thing, or let's say the only difference in here, magnesium has oxidation number of +2 in general, okay? Then we can write the correct formula of your compound. Put in your mind, this will lose hydrogen, and it becomes like this, CH3, COO negative, okay? And here we have Mg during the reaction. You just notice that magnesium here will combine, or let's say will react to give oxidation number of a +2, and it has oxidation number of +1. Then if you make a cross multiplication, the formula of the compound in here will be Mg, you have to open a bracket, and you have CH3, COO negative by 2. So this is a very good, important topic to put in your mind, in addition to H2 as a gas. So this is the only difference, or let's say you have to put in your mind the oxidation number of magnesium when it's in a compound. Okay, let's go to the second part of reactions, which is reaction of carboxylic acid CH3, COOH plus NaOH. You just remember something. In this case, we have a neutralization reaction. We have neutralization reaction. Okay. The neutralization reaction products indicates that you will have a salt, and the salt here is the combination between Na and the carboxylated group, and you will have CH3, COONA, and it works as a salt in addition to the water molecule plus water. So this is a neutralization, and this is one of the reactions that the carboxylic acid can make. Let's go to the third reaction that you could have, which is another acid, CH3, COOH, and it reacts with metal carbonates. So let's take an example of Na2CO3. This is metal carbonate. We just remember this is acid-base reaction. Okay, but in addition to this reaction, we notice that we have carbonate, and we're supposed to have carbon dioxide, in this case as a gas. So the product will be, the Na will combine to this one, and we will have the same salt as we have here, and it appears like this, CH3, COONA plus, and then we have water molecule and then carbon dioxide. Another famous reactions of carboxylic acid, which is the reduction of carboxylic acids. When we say reduction, we're going to use reducing agent. And the only reducing agent that is enough, or let's say able to reduce the carboxylic acid, is lithium tetra tetrahydroaluminate. Okay, so this can reduce the carboxylic acids. Carboxylic acids. All right, so what will be as a result of a reduction of carboxylic acid? So let's take a real example, and we're gonna go to our normal example. CH3, COOH, we apply LiAlH4 in the presence of dry ether. And by the way, it happens at room temperature. You will change this to primary alcohol. Okay, so the C double bond OH will change to CH2OH, and then you will write the compound as it is. So we will write CH3, we will change the C double bond OH to CH2OH. So this is the primary alcohol that you have. Put in your mind, we have another reducing agent which was about NaBH4. This is not enough to make reduction for carboxylic acids. It can reduces only ketones and aldehydes. Lithium tetrahydroaluminate reduces carboxylic acids only. Okay, but you can use lithium tetrahydroaluminate and NaBH4. They can reduce ketones and aldehydes. Okay, so this is the main topic that you have to put in your mind.